Okay, we're going to work number 4 on the released items from the 2023 AP Calculus AB exam. Here's number 4. Looks like we have a graph. Function f is defined on a closed interval from -2 to 8. Satisfies f of 2 equals 1. Oh, f prime. F prime is what's graphed. Function f is defined on the closed interval and satisfies f of 2 equals 1. Graph of f prime, a derivative of f consists of two line segments and a semicircle as shown in the figure. Does f have a relative minimum, a relative maximum, or neither at x equals 6? Give a reason for your answer. So we have 2023 AP Calculus AB FRQ number 4. And part A says, does it have a minimum? So, because f prime of 6 equals 0, x equals 6 is a critical point. But because f prime of x is greater than 0 in the neighborhood immediately to the left and right of x equals 6, f prime of x does not change sign at 6. Therefore, f of x has neither minimum nor maximum. At x equals 6. Because f prime is positive, f is increasing, and then f prime equals 0 here, critical point, but it continues to increase beyond that. Therefore, there's no minimum, no maximum. On what open intervals, if any, is the graph of f concave down? So f is concave down when f double prime of x, which equals f prime of x prime, the derivative of f prime of x, is less than 0. The derivative of f prime less than 0 on -2 to 0, because the slope of the tangent line is negative. The rate of change of a linear function is a slope. The slope is negative, so the slope of the tangent line to f prime is negative on 0 to -2. Then the slope of the tangent line is going to be negative again from 4 to 6. And 4 to 6, because slope of the tangent line of the graph of f prime is negative on these intervals. Therefore, let's double check the question. F of x is concave down on -2, 0 and 4, 6. Part C, find the value of the limit as x approaches 2 of 6 times f of x minus 3x over x squared minus 5x plus 6. Or show that it does not exist and justify your answer. So f of x, we have f of 2 equals 1. F of x is continuous on -2 to 8, because if we took the integral from f of 1 or f of 2, this area adds up infinitely small, accumulates, so the accumulation function we could just say define f of x as the accumulator function from 2 to x of f prime of x. The x is continuous because the function is defined on the entire real number, and because, well, it's defined on the entire real number, and differentiable, since the derivative of this is f prime. I'm going to go over and put t dt. Because we see by the graph the derivative of f of x is f prime of x, and therefore, since it's continuous and f prime of x is not differentiable, but f of x is differentiable. Okay. And we're doing part C, which says we're going to find the limit. So the limit, f of 2 equals 1. So the limit here as x approaches 2 of 6 f of x minus 3x is equal to 0. And the limit as x approaches 2 of x squared minus 5x plus 6 is going to be equal to, if we plug into this, a continuous differentiable function, so 4 minus 10 plus 6 is equal to 0. So L'Hopital applies. And that means that the limit as x approaches 2 of 6 times f of x minus 3x over x squared minus 5x plus 6 is equal to the limit as x approaches 2 of 6 times f prime of x minus 3 over 2x minus 5. And this f prime of x we can evaluate directly. F prime of 2 is 0. So this equals -3 over 4, which is -1, which equals 3. I believe we've justified our answer there. Find the absolute minimum of f on the closed interval from -2 to 8. So the absolute minimum. So critical points are where the derivative, absolute min of f. The endpoints for the candidates test, we're going to use -2 and 8. And we need critical points also, so that's where the graph of f prime equals 0. So we need -1, we need 2, we need prime is undefined. Prime is defined on the entire interval. And 6. We already said that 6 is not a relative max or a min, so therefore it can't be the absolute maximum or the minimum. We'll go ahead and evaluate though. So then we need to find f of x on those x values. So we know that f of 2 equals 1. And we're going to say that f of negative 2 is going to equal 1. And then the area is going to be going the opposite. Let's go plus the integral from 2 to negative 2 of f prime of x dx, which equals 1 plus the initial value plus that accumulation function. And so this is going to end up being, I'm going to go ahead and switch these, negative 2 to 2, f prime of x dx equals 1 plus, and this is going to be, the area here is going to be 2 times 1 times 1/2, or 1. And then it's going to cancel this out to make that 0. And so this is going to be half of 4, which is going to be 2, or 3. So f of negative 2 is 3. F of negative 1, I should have subtracted that. That's my bad. I should have subtracted that. It's going to actually be negative 1. And f of negative 1 is going to equal 1. We're going to go ahead and subtract this and switch these. Go from negative 1 to 2. F prime of x dx equals 1 minus, and then the integral from negative 1. This is going to be negative 1 and negative 2. Did I do that right? This should have been negative 2 coming this way. And since I was subtracting it, it would have been negative 2. And so that would be 3. That was correct, 3. Three was correct. That should be plus. This one will be negative 1, negative 3, plus 1. So I'm subtracting, so again, negative 3, and this is going to equal 4. That's 4. Then we're going to do f of 6, which is going to be 1 plus the integral from 2 to 6, and that of f prime of x dx. So this is going to be 4 minus 1/4 of the semicircle, or 1/4 of the circle. So pi times 2 squared, 4 pi is the area of the circle.
Attention students, 11-12 lunches will be only in the cafeteria.
Divided by 4, that's the area in here, and we have to subtract 4 minus that. So 4 minus pi, 4 minus pi is going to be this part, plus 2. So this is going to be 1 plus 6 minus pi, or 7 minus pi, that's 6. And then 8, f of 8, we're going to go ahead and evaluate this, even though we could probably stop now and just say that f of 2 is going to be the minimum. F of 8 is going to be 1 plus, if this was pi, this was pi, or sorry, 4 minus pi, and 4 minus pi is going to be 8 minus 2 pi. So this is going to be 1 plus 2 plus 8 minus 2 pi plus 6 minus pi. Did we get that right? Four minus pi plus 2, yes, okay. So this is actually going to be 11 minus 2 pi. So the absolute value, or absolute minimum, at x equals 2 is 1. And that should be correct. And that should be the end of this video.